Hey, welcome back to all of you cool cats and kittens to another lesson for geometry, lesson 116. So we're 4 away from finishing the book. Yeah. This lesson today is going to be secant, cosecant, cotangent. It's not very hard. It has to do with sine, cosine, tangent. I just want you to understand what it is so that you don't make a mistake. But because there's a common mistake, especially when you do it in your calculator, right? So when you're going to do it in your calculator, you have to know what the difference is between cosecant, secant, and cotangent, and inverse sine, inverse cosine, inverse tangent, because people get confused all the time. This is one of the reasons I had to do this video, but I don't mind because I like you more than the other kids. So yeah. Let's actually get into the video. All right, so let's actually start with the very basic. Sohcahtoa, sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that's pretty easy. So what are the new ones we're learning today? The ones we're learning today are cosecant, secant, and cotangent. All right, so cosecant, secant, and cotangent. You don't have to really memorize the whole name. Just know how to say it and learn the shorthand. So this was sine, not sin, sine. This is cosine, not cos. And this is tangent, not tan. So cosecant is CSC, cosecant. Secant is SEC, secant. And cotangent is COT. All right, so what does it mean? It means, and why did I draw the lines, the little arrows, I mean? The arrows have to do with that order, and that's one of the reasons that I always encourage students to learn it that order. Cosecant, secant, and cotangent. Cosecant, secant, and cotangent, okay? It's really important because if not, you're going to have a really big problem, and I don't like the way that your book says it, secant, cosecant, cotangent. No, it's first cosecant, then secant, then cotangent. Why? Because cosecant has something to do with sine, secant has something to do with cosine, and cotangent has something to do with tangent. What is it? Well, they're reciprocals, meaning that we flipped the order. So cosecant is the hypotenuse over the opposite. The secant is the hypotenuse over the adjacent. And the cotangent is the adjacent over the opposite. So it ends up being that this is the same thing as 1 over sine theta. This is the same thing as 1 over cosine theta. This is the same thing as 1 over tangent theta. They're reciprocals. This is one of the reasons that people get confused with inverse sine, cosine, and tangent, because if I say that x to the negative 1 is 1 over x, then most people say, oh, okay, then sine equals this. No. Sine, inverse sine does not equal 1 over sine. Inverse sine is not cosecant. Inverse sine is a way to actually find theta. We don't have a theta here. We do have a theta here. So you have to understand the inverse sine or inverse cosine or the inverse tangent are not about finding the cosecant, secant, and cotangent. It's about finding theta. It's about finding the angle. And this is not about finding the angle. This is about finding the ratio of the hypotenuse over the opposite, the hypotenuse over the adjacent, or the adjacent over the opposite. So that's why it's not super hard, but you need to understand that it's not the same thing as the inverse, okay? So let's actually move on to some of the examples. Hopefully this is clear. This is not very hard, especially if you know Sohcahtoa, then you will know. However, I know one thing. Because this one starts with a C, cosine. A lot of people say, oh, cosine goes with cosecant. No, wrong. Cosine goes with secant. I don't know why they did it that way, but that's how they did it. And sine doesn't go with secant. I know both start with an S, but they don't go together. Sine goes with cosecant, okay? So sine goes with cosecant and cosine goes with secant, all right? That's very important. Cotangent and tangent, that's pretty obvious because tangent, cotangent, pretty easy. All right, so let's actually go into one of the examples so that Isabella doesn't get confused. Okay, hopefully she understands all this. But let's see what happens. All right, so example 1a, they give us this triangle STR, and they tell us, okay, so in this triangle, find the, and they go like this, secant, cosecant, and cotangent. And I'm saying, no. I'm going to break that cycle because your guys are going to get confused with sine and secant. They don't have anything to do with each other. So I'm going to start with cosecant, because we usually start with sine, then cosecant, not cosine, cosecant, then secant, then finally cotangent. So cosecant, as your book says, it's going to be 1 over sine theta. 1 over sine theta is the same thing as the hypotenuse over the opposite. The hypotenuse over the opposite then would be, opposite is B, hypotenuse is C, so it'd be C over B. Yay! So this one is 1 over cosine theta, which is hypotenuse over adjacent. So the adjacent is A, hypotenuse is C, so it'd be C over A, because it's the hypotenuse over the adjacent. And this one then would be the adjacent, 1 over tangent theta, which is the same thing as adjacent over opposite. And so that would be adjacent A over B. So I finished the first part of this example. Let me just check the values they give you for the second part, and we'll be right back. All right, for the second part of this example, this is so easy that even Lydia can do it. So we're going to have this one right here, and it's going to be cosecant theta. Theta is right there. C is going to be 97. They're not asking us to find the final number, just the ratio. So it's going to be 97 over B, which is 72. Yay! Then we have C over A for secant theta, which is 97 over 65. And finally, we have cotangent theta, which is A over B, which is going to be 65 over 72. And there you go. Everybody should be able to know how to do that because it's pretty easy. So now we're going to actually talk about those beautiful identities that we went over. And you remember that class in which I wrote a bunch of things on the board to find the different identities. Now we're going to do the identities based on what we know about cosecant, secant, and cotangent. Okay, so yay, hooray math. Okay, so this one, we have this identity, which everybody should know. Sine squared theta plus cosine squared theta equals 1. I hope that everybody remembers that. And so we're going to actually divide it into two parts here. We're going to divide by sine squared theta, everything. So we're going to have sine squared theta plus cosine squared theta equals 1. If I divide everything but sine squared theta, sine squared theta divided by sine squared theta is going to give us 1. Yay. And then we have plus cosine squared theta over sine squared theta. So I hope that you remember that tangent equals y over x, all right? Or that you remember that tangent is the same thing as sine over cosine. So cosine over sine would actually make it cosine squared theta over sine squared theta would actually make it cotangent squared theta. Okay? And then finally we have 1 over sine theta, sine squared theta, which is going to be cosecant squared theta. And so to actually make it into what we need to do, we're supposed to subtract cotangent from both sides. Cotangent squared theta. And so we have our first identity. 1 equals the cosecant squared theta minus the cotangent squared theta. Yay! Just making sure I have it. I have it right. And then the second one, we're going to do the same thing. Sine squared theta plus cosine squared theta equals 1. Then we're going to divide the whole thing by cosine squared theta. Sine over cosine is going to be tangent, regular tangent. Let me just do it like I did it here. So it's going to be sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta over 1 over cosine squared theta. Okay? So hope everybody sees that. Sine over cosine, as I said, is going to be tangent squared theta. And cosine over cosine is going to be 1 equals 1 over cosine squared theta is going to be secant squared theta. Then we're going to subtract tangent from both sides, tangent squared theta. Our next identity is going to be 1 equals so now we have two identities. 1 equals secant squared theta minus tangent squared theta. And we have 1 equals cosecant squared theta minus cotangent squared theta. That obviously comes from the one that we already did a while back. I don't remember what lesson it was, but we did it. And we know it's sine squared theta plus cosine squared theta equals 1. Hooray! Obviously, this is super easy, and I hope everybody knows how to do it, remembers how to do it. Maybe we'll have it in the next test, which is after lesson 120. We're going to have another test, and then we have the final exam. And that's pretty much it for geometry. All right, let's move on. All right. In the last example for this super long lesson, it wasn't that long. And by the way, you didn't really need to use your calculators either, but for your homework you might, and for your tests you might as well. But this is pretty easy because they say, okay, we have secant theta equals 2. We don't know what theta is, okay? You don't have to worry about theta because that's not the question. They say in a right triangle where the secant is 2, what is the tangent of that triangle? So you don't have to go around looking for theta because we're assuming we're all talking about the same angle. So we have, okay, so the first thing that we need to do is remember what we just did with the identities, right? So one of the identities was 1 equals secant squared theta minus tangent squared theta. That's literally one of the identities that we just did. And so we know that secant theta is 2, so we're just going to put the 2 right here, but don't forget that it's squared, so it's going to be 1 equals 2 squared minus tangent squared theta. Don't forget about those squares, so it's going to be 1 equals 4 minus tangent squared theta. And then you're going to subtract 4 on both sides. Yeah, that's fine. You're going to subtract 4 on both sides, so this is going to become negative 3 equals negative tangent squared theta. Yeah, but we don't want those negatives there, so let's divide the whole thing by negative 1 so that it becomes, right here, 3 equals tangent squared theta. Well, we didn't solve it because we're not looking for tangent squared, we're looking for tangent. So then we're going to square root both sides, and we're going to have square root equals tangent theta. So tangent theta is square root of 3. And that's pretty much it, how you do it. So the reason I wanted to record this more than anything is because I wanted to make sure your book doesn't mention it, but that you don't confuse cosecant theta, secant theta, and cotangent theta with. They're not the same. They're not the same as sine, inverse cosine, inverse tangent. They're not the same. If you're going to do it in your calculator, what you actually have to do, for example, is find cosine of, let's say, 30. Oh, I have my calculator here. I surprised even myself. Wow, such a magician. Cosine of 30. Was it cosine that I was looking for, or is it cosine of 60? Let's see, cosine 60. Yes. Let's pretend I wrote 60 right there because, you know, I'm like that. I'm a genius. And so it's going to be 0.5 or 1/2, right? So to find the, oh, look at that. I already found theta over here. Inadvertently, I did. That's how smart I am. So cosine 60 degrees is 1/2. And the one that goes with cosine is secant. Remember, secant and cosine, they are inverse. They're inverse. Okay, they're not inverse. Sorry, they are reciprocals. Not inverse, but reciprocals. Let's write it there. Reciprocal. Wow, reciprocal. So because secant is the reciprocal, it will be 1 over cosine. And you can actually write it in your calculator like that, 1 over cosine 60, and you will see that it will be 2. Can literally show you so that you guys can see it. Okay, you ready for, sorry for moving you. I'm gonna just zoom in with my calculator. Make sure everybody can see it. I don't have anything written yet. I'm gonna make a fraction. If you are wondering where I got this calculator, I had to buy one because somebody borrowed mine without me knowing. Let's just say that. So it's going to be 1 over cosine 60, right? You're literally going to put that for secant of 60 degrees, and look at that. I got 2, and in the board, you can't see. Let me just try to... Cosine, you can see it over there. 1 over cosine 60 equals 2, which is the secant, and that's what I wanted you to learn. All right, guys, I will see you guys in the next lesson, lesson 118, which is the last lesson I would actually record for you guys. And I have to do it just because we're going to find something called the determinant of a matrix, which is actually something that you will be doing more than anything else next year in regards to matrices. So, or matrices, like Legia would say, right? Matrices. Miss Anna, I can't find the matrices. All right, see you.